What will it print when I run this? First, I'm importing NumPy as NP, and then I'm making a list of numbers and converting it to a NumPy array. Down here, I'm doing the same thing. They can be different numbers. They don't have to be the same ones. I'm assigning a variable to those. Then down here, I just simply put a plus b. So what it should do is it'll take 1 and 1 and add it together to make 2. Then it'll take 2 and 2 to make 4. Then 3 plus 3 to make 6. I'll run that in a little bit. I'm going to first, though, show how to do multiplication. So I'll just copy this and come down here, paste it. I'll do multiplication, so times. So what this should do is 1 times 1 is 1, 2 times 2 is 4, and 3 times 3 is 9. So if I run that, 1, 4, and 9. Okay, now instead of multiplication, what if I do division? So you have 1 divided by 1 is 1, 2 divided by 2 is 1, 3 divided by 3 is 1. So it should be a list or a NumPy array of 1, 1, 1. Yep. See, it puts a decimal there because the division, it assumes, will need a decimal point because they usually do. Just say if I change this to a random number like 7, it should say something like 0.142857 or something like that as the first one. Yep, 0.142857. Okay, and then the next ones are decimal also. So what if I do raised to the power of? Okay, a raised to the power of b. So it'll do 1 to the 7th power, which is 1, 2 to the 2nd power, which is 4, and 3 to the 3rd power, which is 3, 9, 27. So 27. So it should be 1, 4, 27. Yep, 1, 4, 27. Okay, now what if I subtract? Let's see, come over here, subtract. Now I have a minus b. So 1 minus 7 is negative 6. 2 minus 2 is 0, and 3 minus 3 is 0. So if I run it, negative 6, 0, and 0. But I can also do the modulus operator. So if I say a mod b, then it'll take a, like 1, and divide by 7 and return the remainder. Then 2 divided by 2, this one I'm going to change it up. I'll make it 10 divided by 3. So guess what this will do? Okay, put your guess in the comments or just pause and think it through. Okay, so what the modulus operator does is it'll take, just say 10 divided by 3, which is 3. So because 3 times 3 is 9. But there's a remainder of 1. So this will just return the remainder only. Okay, so if I run this, then 10 divided by 3 is 9 with remainder 1. So that's what it returned the 1. Okay, so now there's floor division, which it will just round it down. Like if there's a decimal, it'll just remove that decimal and round it to the lowest number. So 1 divided by 7, it's less than 1, so it'll round to 0, round down to 0. 2 divided by 2 is 1, so it'll stay there. 10 divided by 3 is 3 remainder 1, but it'll just round down to 3. So let's run it, and 0, 1, and 3. So that's how you do those. All right, now for the addition. So I'm going to remove that, come back up here. So based on the pattern you've seen, it should add 1 and 1 to make 2, 2 and 2 to make 4, and 3 and 3 added to make 6. And it likely wouldn't have a decimal place, so because there's no decimal place to begin with. Because Python in the background, or NumPy, it would assign different types of data. Like this would be just probably an 8-bit integer in NumPy. And let's see, if I'll do a dot, I think dtype is the keyword. hold on, I'm gonna comment this out real quick. Okay, a.d type. This is a int 64, but if I put a 0.2 in there, everything's going to convert to a float 64. So those are different data types. But since none of these are floats, then it'll just leave it as ints. Okay, what that means, the 64 is there 64 bits representing the value. The bits just mean are the transistors inside the computer turned on or off. So this is 64 transistors, and the possible values are 2 to the 64th power, which is like uh, some crazy high number, like in the, let's see, billion, trillion. I think it's in the trillions, quadrillions, or quintillions or something. So you can just do the math on it. 2 to the 6, yeah, 2 to the 64th power. So, and real quick, I'll do 2 raised to the 64. Yeah, that's how many it comes out to. That's how big the numbers can get in a 64-bit. Okay. All right, so now the uncomment this and see what the result is. So 1 plus 1, 2 plus 2, and 3 plus 3, and go. Result is 1 plus 1 is 2, 2 plus 2 is 4, and 3 plus 3 is 6. So that's how you add, subtract, multiply, divide, do remainder, the modulus, remainder, and floor division and exponents in Python with NumPy. If you want to see more details about how some of this with PyTorch, which is similar to NumPy, how that works, then check out some other videos. And thanks for watching, and please click like and subscribe.